Welcome to this session. See, in this session, we are going to see the last two lab programs. So in this implementation, we are going to check with two last topics. So the first one is a MapReduce and the last one is a Tic-Tac-Toe game. So in this, we are going to check with MapReduce first of all. So with the help of the MapReduce, we are going to see the word count application. Right? Now, what is MapReduce first of all? See, MapReduce is nothing but it is having the responsibility of processing the large data, larger files. Okay, so MapReduce has two important tasks. So where the first will be mapping and the second one is the reducing. So mapping is nothing but it is going to split the data. Okay, so we are going to split the petabytes of data, I mean the large data into the smaller chunks. Okay, so after division, we start processing them parallelly on the Hadoop systems. Okay, Hadoop commodity systems there. And at the end, it aggregates, I mean, it reduces the data from the multiple servers and returns a consolidated output. So this consolidated output may be the optimized output, right? So the first task is a map function, second is a reduce function. So in the map function, we are going to convert the data into small sets of data. So we say that as a individual element. So set of data maybe, see, can you see here, input is like this, we have given different kinds of data at one place. Now the output will be bus, we have one, car, we have one, bus, we have one. So like this, we have overall individual set of data. Now reduce is nothing but where we have multiple data repeated n number of times. So all the data we are going to combine. See, wherever we get bus, we are going to analyze that and we are going to see in this application, if we take this application, we are going to reduce by giving the count with the increment operation. So that is what we are doing. See, bus, whenever we get bus, we'll increment by 1 and we will reduce the data, right? So bus 1, bus 2, next bus 3, next bus 4, bus 5, bus 6, bus 7. So at last my output of the reduce will be bus will be 7. Okay, car will be 7 and train will be 4. So these are the smaller set of tuples. So we have finally converted into the smaller set of tuples. So that is what is a reduce function operates. So if you can see the workflow of this particular application, we take some input, larger set of input. We will split accordingly with the cluster content. So after that, we will map that with respect to the wherever. See, bus comes under this category. This bus comes under this category. Next, car category. At last, we will be moving into the plane category and train category. So that we will be knowing how much of the data we have reduced, how much the redundancy data we have reduced. At last, the consolidated data we will be getting as one output, right? This is all about the MapReduce. So for this, we have 5 steps while we are seeing here also, you can see we have splitting, mapping, intermediate splitting. See, intermediate splitting is nothing but what category comes under which sector. So that is what we do. Next, reduce and then consolidate with the combination. So these are the 5 steps which we involve here also. And now coming to the implementation part, we can do this with the Java project. So you just go to the the Eclipse IDE. In that IDE, you just open a file, new project, and you go with the any name, that may be your name also. Just click on finish so that your new project will be created. Now right click on the new project and right click and you go to the new package and you just develop it. Name the package as a package demo and just click demo. Now right click on the package. See, now after the creation of the package, you just right click on the package, go to the class and the class name which I'm giving as a word count, because the class which I'm going to use later is the word count class. See, can you see this? So for that purpose, we have created the class word count. Now you start adding the libraries from the Hadoop core.jar and commodities, all this whatever required jar files we need as a packages. You just implement all those, and all the packages comes under Hadoop versions only. So till here you implement all the Hadoop sectors. I mean for the configurations, for the path, for the writing purpose for the MapReduce, and we have a reducer separately, we have the mapper separately, and the input output formats. So for all this purpose, you just take all the required packages with the Hadoop version, right? Next, you go with the word count. So in the word count, we are taking the arguments. So whatever the arguments we are getting, we are saving all the arguments as a files. Okay. So in this files, we are going to start finding the word count over there. So whenever we get a word which is of the same type, we have to go with the reducer class. Okay. When we get different types of classes, you just go with the mapper classes and set that in that particular class, right? So now here, see here, words, I'm going to split every like total string, you divide into the words. Now every word, whatever we are getting, so every word, see, for every word we are saving in the word, and if the word is already available, you just trim that and save the value. If the word is not available, you just write that value and then go with the new data. So that is what we are doing. And at last, we are going to print the sum value, and you just print the output as a sum. Every word with its sum. Every word write its sum. Okay. So that is the input. See, take the data like this. See, for taking the data from the text file into HDFS format, we have to do this. Just Hadoop fs minus word count file. See, whatever the file we want, so that particular file, you just move into the Hadoop directly. Okay, HDFS format. See, after that, you just give the terminal, I mean the command area, you just give this Hadoop jar files so that you can see the files, whatever we have over there. So at last, you will be getting the output as bus as 7, car as 4, and train as 6. So with this help, we can do the, this is a very small applications where we are just going for word count applications. Like this, we can go with a number of applications where the MapReduce model will be playing an important role. The next one is the Tic-Tac-Toe game. So coming to a Tic-Tac-Toe game, we can go with just as a Java version, or I mean just as a Java code, or it's the Android SDK. Okay. So first of all, let us see the Tic-Tac-Toe game with the .java, only Java. So at last, we should have the winner as a thing, right? The final aim is to give the winner. So for that, we should create the board first of all. So the board should have 3 by 3, where 3 by 3, the first row, if X, I have taken two users, X and O. X and O. So if X gets 0, 1, 2, so he is the winner. And 0, 0, 1, 2, 3, 4. So index 4. 0, 4, and 8 also the winner. So like that. So this is first row winner. This is second row winner. This is third row winner. Similarly, this is first column winner, second column winner, third column winner. So the options, in how many ways a user can be a winner. And this is a top left to bottom right diagonal. And this is 2, 4, 6 will be the top right to bottom left diagonal. Okay. So if we get a line of all X, see, I have given X user and O user. If all X is there, means we have to declare the winner as X. If all O is there, we have to declare the winner as O. And all this board information I'm saving as the array list over there, right? So this is a board, how to like the view of the board. This one is a view of the board. And at last, we are going to give, means the turn, means after the X gives, next O must give the turn. Like that, I have coded here. You just go through the code once again. I will be pasting this in the description area if required, if anyone requests. Okay. So next, at last, we are going to print the board with the winner. Okay. So every time we have to render the board if it is the application which is like proper application. If it is just like this Java code, means this will be the scenario. See, I have 1, 2, 3, 4, 3 by 3 matrix over here. So I have given chance for X first of all, X. So X got chance to utilize at what place he wants. So I gave 1. So X. Next, 0's turn, he gave 4. So 0 at 4. So like this, we will be executing the processing. So at last, it's a draw because no one won here. So it's a draw. So at last, we will be giving the thanks for playing message. And in the similar way, we can code this for rendering purpose. Every time we have to give the code for rendering the new, the application, whatever, see in this format, Android version. So that the expected output will be like this, touch based. So where we have to render our window every time, after every extern and after every O turn, we have to render the window. Okay. So the backend will be the same content only. So if we start seeing the output, yeah, we'll close this. Yeah, CLS. Java C, tic tac toe dot Java. Done. We have done with the proper execution. Now let us go with the, yeah. See, this is the 3x3 tic-tac-toe and with the proper indices. Now, X is given with the initial opportunity. X will play first. So it enter a slot 2. So I have entered 1. So X, 1 slot is fixed to X. Now O's turn, I gave 5. Now X turn, see, you can see the rendering option. This is just a output version, but if it is application version on the Android, the window should render all the time, refresh every time. Now I gave 4, right? Now I gave O's turn as 8. Now I gave X turn as 7. See, congratulations, because I have done with 0, 0, 1, 2, 3, 3, 0, 3, and 6, right? X has won. Thanks for playing. So in this way, we will be completed with the lab portion. If you have any doubts, please feel free to contact anytime in the college. Thank you.